Simmons, and I am going to be demonstrating how to perform the gas laws lab. We are going to be experimenting with Charles' law, which says that the volume and the temperature of a gas are directly proportional when the pressure is constant, which means that if I heat up a gas, it will expand. So what we are going to do is we're going to be heating up a gas in my Erlenmeyer flask. What's the gas? Air. Inside my Erlenmeyer flask is the gas. What's the volume of the gas? Well, it's going to be whatever the volume of inside the Erlenmeyer flask is. So the first thing you're going to do in your lab is figure out that inside volume by filling the Erlenmeyer flask up with water, putting the stopper on so that the water, there's no air there. And here we go. Here, the water inside here is now going to be the volume of my gas. How am I going to do it? Well, I'm going to fill up my graduated cylinder. Too much for the graduated cylinder, so I'm going to have to do it a couple of times. You get the idea. There's 100, 200, and then whatever is left, about 260 milliliters. But you're going to take the exact measurements. Then the next thing I'm going to do is put my stopper on. I'll have dried all of this out. Dry, dry, dry. And I can heat it up on my alcohol burner in a beaker. But this is a little bit too flimsy for me. An alternate way that you can heat things up is on your stove. I have a pot of boiling water on my stove, and I'm going to lower my Erlenmeyer flask in this so that I heat up the air inside my Erlenmeyer flask. It's a little tricky because it's going to resist going to the bottom. And I'm going to try and get the level of the water as high in my Erlenmeyer flask as possible. I'm going to submerge this in boiling water for 5 minutes. At 5 minutes, the temperature of the air should be the temperature of the boiling water. What temperature is that? 100 degrees Celsius. All right, so once I do that, heat, I'm going to clamp my Erlenmeyer flask. Now I have the gas. It's at 100 degrees Celsius. I know the volume. That's going to be my first data point. Now I'm going to take this to my cold water bath. This is my cold water bath. And I'm going to submerge the Erlenmeyer flask totally in my water bath. I'm now going to hold it because it'll cool down enough. It's in ice water. It's a little uncomfortable. I can take this clamp off. I'm going to wait till the air in my Erlenmeyer flask cools down to 0 degrees. That's going to take 5 minutes, a little uncomfortable because your fingers are going to be in ice water for at least 5 minutes. I am going to take the clamp off the rubber hose, and what's that going to do? That will allow the water from the bath to enter the flask according to how much the gas inside the flask is contracting because you're taking it from 100 degrees down to 0 degrees. After 5 minutes, I'm going to put the water, raise and lower my flask so that the water level inside the flask is at the level of the water of my bath, at which point I will then clamp the rubber hose, and everything has to be done underwater. And now what we have is a little bit of water inside the flask. The water that has entered is going to be proportional to the gas contracting. So now I can measure this water with either my 100 or my 10 milliliter graduated cylinder, and you have to have it even. This is exactly 12 milliliters. So the volume of my gas at 0 degrees is no longer the total inside volume of my Erlenmeyer flask. The volume of my gas at 0 degrees is going to be the total minus my 12 milliliters that I measured of the water that entered the flask at 0 degrees. So that's the second data point. Then I start all over again. I stopper my Erlenmeyer I take it over to my boiling water. I heat it up for at least 5 minutes so that I know that the air inside the Erlenmeyer is 100 degrees. After that, I clamp it, take it out, and take it over to a second water bath at the temperature that I want, either room temperature or then a warm water bath closer to 50 degrees Celsius. Don't use a water bath over 55 degrees Celsius because that's scalding. And we have to immerse our hands in this water. I don't want you to scald yourself. All right, that's how to do the lab. Have fun.